Dr. Gold in the lab, Twitch stream glowing, formulas flashing, minds wide, knowledge flowing, equations on the board, numbers never sleep, teaching math and physics while them haters count sheep. Actual education, tune in and get schooled, flipping textbooks, breaking all the rules, from Newton to Einstein, concepts elevate. Keep the stream, it's the key to our fate. Dr. Gold dropping gems, knowledge raining down, actual education making scholars all around. Perpendicular minds, angles sharp as ice, maths and physics, yeah, the future's real nice. Got the Pythagorean triangles about to flex, quantum theories on deck, breaking all the specs, relativity theories, worlds getting small, grasp the universal laws, standing tall. From the atom to the cosmos, we rolling deep, grazing up the stars, no time to sleep. Black holes and supernovas, concepts we unfold, brain power heavy, yeah, that's Dr. Gold. Dr. Gold dropping gems, knowledge raining down, actual education making scholars all around. Perpendicular minds, angles sharp as ice, maths and physics, yeah, the future's real nice.
Alright, what's up, everybody? My lo-fi hip-hop beats. Where are my hip-hop beats?
This is your brain when you're struggling to focus.
I don't want ads. Don't give me the ads. YouTube. There you go. Much better. What's up, X? Yes, sir. What's going on, dude? Let me see. Oh, is Twitch not working? What the fuck? What the hell? 1 second. I don't know why it's not working. What is this? This trash. There we go. Is it detecting it at least? Okay, good. It is detecting it. Right. Nice. What are we going to learn today, Mr. Tutor? Whatever you guys want to learn. It's office hours. People ask questions. Things happen. What's up? Nasser says, hi, I wanted to ask about how to deal with a missing homework assignment due to a medical problem that I face. I sent you an email and I can provide whatever information is needed for me. Yeah, sure. If you got like a medical emergency, just send me some proof or something. I'll give you like an extension on it. Because, yeah, we're not dropping any homework assignments. There's not even that many, honestly. I think there's like, what, 10? 9 or 10 homework assignments? Maybe less, honestly. I forget. But, yeah, it's not that much. I always tell students that, like, you get a week to do the homework. Don't wait till the last day to do it. Because there's always something that can happen. And that's why we give you a whole week to do it. Try to do it as soon as you can. You know, if you wait till the last minute, some professors just won't give you any sympathy. They'll be like, yeah, nope. So I'm always trying to like prepare students for what happens when they deal with people that aren't me. If I set expectations of like you can just like ask for extensions, get whatever all the time, it's kind of a rude awakening when you get to another professor and they're just like, nope. No. Jeff says, are phase diagrams based on experimentation or can you derive phase diagram from atomic formula? What phase diagrams are we talking about? Phase diagrams of what? There's a lot of different types of phase diagrams. Oh, state diagrams. Oh, like liquid, solid, gas, all that. That's a good question, actually. Let me ask. Let me go Google that for you. I'm curious. I mean, I think they're probably empirically derived, but... X says, how can I go pro in Fortnite? Practice. So, Jeff, apparently phase state diagrams, yes, are primarily determined experimentally. But you can use theory to try to, like, help. Because, yeah, you can talk about, right, yeah, the van der Waals forces, the Clapeyron equation, Gibbs free energy. Yeah. So, yeah, there's definitely, like, theoretical models we can come up with. But the main ones you see are probably experimentally determined. And, like, things follow nice curves in life, right? Stuff's continuous. Or at least we hope it is. Okay, today is Wednesday, middle of the week. Looks like we already got some more questions people are asking. Ooh, nice. Mickle, you asked a good question. Yeah. All right, we'll go over this in a second. This question that Mickle asked right here. This is a good one, Mickle. What's up, Sib? But otherwise, server news. We're gonna do a Fortnite tournament this weekend. I'm gonna announce it tomorrow. So if you're around to play Fortnite, or want to play Fortnite, or have never played Fortnite, or just want to, like, you know, have some fun playing video games with other people in the server, we're gonna do that on Saturday. So I'll make an announcement in the stream later, in the Discord. For my UCLA physics people, we have one more lecture tomorrow for this week, and then there's no lecture on Friday because you have an exam. I just kid. It's not gonna be that bad. Don't worry. Trying to think anything else. Not really. Yeah, no, I spent a lot of today working on writing up the exam, and then I gotta like put it into Kudu, which is gonna take some time. And what else was I doing? I was I emailed some art cars for Burning Man. Trying to get myself to play on another art car for Burning Man. That was a lot of fun last year. It was actually kind of like random. I was just walking around and I recognized someone that I had done cello stuff with like a year prior, and he's like, "Oh, this is my friend's art car," and I was like, "Oh, sick." And then I went in and met the DJ, and then I gave him my USB for, like, because he was playing to a pretty big crowd, and I could tell like he was getting into what's kind of like the pop remixes. So like EDM remixes of pop songs, like think like, you know, 50 Cent, like I don't know, Lil Nas X or something, but like electronic. And I had like a really good remix of Industry Baby, and I gave him my flash drive. I was like, "Here, dude, you need to play that song next." And he did, and it was dope. And then he turned to me, he's like, "You want to finish out the set? Like, I'm kind of done." I was like, "Oh, sick, nice."
Nice.
So then, yeah, I played an art card at Burning Man because of that. So you never know what's gonna happen. Just put yourself out there. It's kind of fun. Oh, what's up, Mondo? That's dope.
That's dope. That's dope.
Mondo, when are we playing the finals again, bro? Dude, I haven't played in like a week and a half. What's this, like, David's going on he does this. He's hilarious, bro. He goes on what's it, like a dopamine detox now, where he says, like, I'm going to stop playing video games. I'm going to stop, I don't know, to reset my dopamine. But then he's like sending me like 4 Instagram reels a day. Like, I'm like, you're just replacing one dopamine system with another. That's all you're doing. We can have like restraint on things. He is so hilarious. Yeah, with the product. I'm like, bro, we can just play like an hour a day. It's totally cool. We can just play the finals. I'm down to just play. Yeah, I get it. Some people like get caught in these loops, and then they need to do these like big breaks to get out of the loops. But it is hilarious to me. It's too funny. Wow, 1020. Yeah, so Mondo's a really good player. He's trying to get to Ruby, I think, eventually with ranked. He's really good. Mistral says, I hate the tanks with freaking flamethrower no skill. Dude, flamethrower goo is like the absolute worst. Wait, I think it was at the beginning of the season. We ran into so many like flamethrower goo teams, and they're so annoying, dude. Nice. Yeah, the problem is like every morning for you, Mondo, it was like 5 a.m. for me, or like 4. So, and now, yeah, I have to be kind of responsible because I teach at like 12:30, and I try to go to the gym at 10, so I can't really stay up till 5 like I used to play. Oh, they're still quite frequent? Damn. Okay. Well, anyways, Mondo, if you want to play on, I don't know, Friday, or like even one of these evenings if you get free, dude, I'm in control of my dopamine. If you want to like play some games, we can do that. Just let me know. I can't even get like Zev to like get online and play. I don't know. He's in like depression land and like just doesn't answer his phone. Try to get your life together.
Oh no.
Okay. Enough analysis of our psyches. All right, here we go. Let's start off the stream. Help you guys with some math and physics. All right, welcome everyone. Office hours. My name is Dr. Skull. This is Actual Education. Streamer helps you out with math homework, science homework, physics, all the fun stuff. We like to play video games too. Oh, Mondo's depressed. He has got to go back. Yeah, so Mondo just recently had a kid. Congrats. And I think he was on paternity leave. So he's in one of those nice free states that gives time off to dads, to be dads. I think that's a great thing, honestly. They always give maternity leave, like, because obviously, like, women get, like, absolutely wrecked with pregnancy. But it's nice that, like, they recognize that, you know, dads who are still engaged with their kids' lives definitely take a toll as well in terms of, like, sleep and stuff. Yeah, 6 weeks paid off. Yeah, that's dope.
That's dope.
Okay, but you're telling me we're not gonna be able to play the finals anymore because you have to go to a job now. Yeah, okay. Sadness. Maybe I should just go out and just go have a kid or something. Although I don't really like officially work for UCLA full time, so I don't think they would pay me any sort of paternity leave. I'm kind of like hired help, honestly, at this point. Yes, Emerald. Yeah, go get your Emerald, and then I'll join you for some ranked. Before you leave us for the Diamond Ruby land. Okay, let's see. A rectangular flat bottom barge, dude. Wow, that's an interesting name for something. With an area of 50 meters squared, is loaded so that the bottom is 1 meter below the surface. Okay. Let's draw some shit. Flat bottomed. Okay, I get the feeling we're gonna use Archimedes' principle here or something, probably. Anytime I see like we're slightly like below something, it means there's buoyancy for sure. Okay, the bottom is 1 meter below the surface. Cool. Let's draw that. One meter below the surface. The density of the water is that's a standard number, and the water is perfectly still. A round hole with radius 1 centimeter is made at the bottom of the barge. Oh, sure. For sure. Yeah, let's figure that out. I assume that the barge is open as well, right? Yeah. Let's like assume here. Let me, because that changes the pressure. Yeah. Let's make sure this is an open barge, right? And a round hole, right, like a hole. Dang, who put the hole in my barge? It's gonna cause this whole thing to sink. Okay, whatever. There's a hole here with a radius equal to 1 centimeter. What's up, Mizan? And water starts leaking in. Oh no. Okay, so the water starts like pouring in. Okay. When the water level reaches 5 centimeters, a bilge alarm will alert the barge operator. How long will it take for the water to reach the level of 5 centimeters? Okay, that's cool. So 5 centimeters, I'm assuming 5 centimeters inside the barge. Right? So they're talking about this maybe. Well, here, let's... or 5 centimeters, sorry. Okay, interesting. So there's a lot of things at play here. Because this thing is like... And they don't tell us... what's that 1K? They don't tell us the weight of the barge. But we do want to use Bernoulli's equation? Sure, I agree with that. I think what I want to say is... Yeah, let's come up with two things. I think I want to say that like P1 is here. Okay? I can like refer to what the Bernoulli equation is for the water here. And then what the Bernoulli equation is for the water right here. FB is W because it's floating right now. Sure. Yeah. Correct. Yeah, it's the point. Yeah, oh, I see. Oh, so actually we could figure out the mass of this thing because I know the volume of water it's displacing. Oh, very cool. I wonder if I need to know that yet, though. Here's the interesting thing, though, right? Is that as this thing fills with water, right? It's going to sink more, right? So now, like, the height of the water changes? Ew. I don't want to know if I have to, like, integrate this. Okay. Let's see. Let me get my Bernoulli equation out. I think what I want to figure out is I want to figure out the velocity of water that's flowing in here. And then from that, I could figure out a dVdt, like a change in water volume per unit time. And I hope that's not dependent on time, because I would love to just multiply that by 30 minutes. But it may be. But then I'd have to determine like how much the height is changing with time. Wow. This could get really complicated really fast. I really don't want it to. I hope we can use like some simplifications. Okay. Yeah, so let's use this. I'm going to say that this is P1 and this is P2. So P2 is at the hole. I think P1 is like the surface of the water. Because what eventually I'm going to say is that like this is 0. Because I'm going to say like the water level of the ocean doesn't change very much, right? As like water starts to leak in. Like the ocean's massive, so it doesn't really matter. And then P1 is atmospheric, right? Which is going to be the same as P2. This is also atmospheric pressure here, so this actually goes away as well, right? So then all I have is this, right? This is rho GH. So what you can think about is, right, the pressure of the water here has to be the same as like the pressure of the water here. In order for like pressure to be like continuous, I think. Pretty sure. Or actually, no, it's not. It's not. No, I take that back. Oh, but the hole on the top. So, sorry, are there two holes? No, it's just one. So P1 is referring to, I'm referring to the Bernoulli equation for the water right outside the boat. Wow, thanks for the raid, Obi. Thanks, brother. I'm referring to what the pressure of the water is at sea level, like outside the boat. That's what I'm thinking. Okay. Yeah, let's talk about, though, the pressure that the water is exerting here. Because this is the same, right, as there being kind of like a piston on top, right? That's exerting like a force. That's going to change the pressure. Yeah? What's up, Nico? He says, hey, G, purely conceptual, but how come magnets don't lose their charge? Shouldn't they even out their charge and become neutral? Oh. I mean, they do eventually, if you, like, thermally fuck with them enough. Magnets are magnetic because of, I think it's, like, magnetic moments that form if something's, like, paramagnetic or diamagnetic. And that's not something that, like, goes away. That doesn't, like, neutralize itself. Unless, again, yeah, thermally. If you, like, overheat magnets, you can, like, demagnetize them. Has to do with, like, the alignment of the spins of their electrons. Okay. You know, I'm going to do it strictly from a fluid standpoint here, Mistral. Let's just say this is rho GH1, okay? So I'm going to say this is rho G times 1 meter, okay, is equal to 1/2 rho. We're going to say, like, V2 squared, so that's the velocity of the water there. And I'm going to say this is plus 0. Okay? A magnet sitting by itself. Okay, I'm going to call this H1. So this is the height. This is H1, right? And I'm going to call this height equal to 0, is what I'm going to say. Although, yeah, the issue is that that height's going to change, though, right? As this thing, like, fills up with water, right? Let me think. This is a differential equation is what it is. Yeah. Okay. And actually, you know what happens as this thing fills up with water? Mistral? It's actually pretty cool. This thing goes down, right? But I think the water level stays at the same amount. And the reason being is your buoyancy, right? In order for this thing to be floating, you still need the volume of space that's being occupied by air to be equal to the weight of the weight of the object. The weight of the object's not changing, right? So whether I'm here or let's say I'm here, and I have some water occupying it, I still have like this much space to provide buoyant force. Like I could let some water into the boat and the boat should still float. The point at which the boat does not float is when this gets lower than the water level, and now there is no space of water that's being taken up by air, right? Because now the whole thing's just full. Yeah. So that's why like things will float, right? Until there's no more buoyancy that can keep it up. Okay. So I think there's a couple tricky things here. I'm going to call this 1. This is fine. Okay. This is not going to be 0 though. This is going to start at 0, but as water flows into this, okay, that height is going to increase. Okay. So there actually will be, so the hole, right? The hole is going to move down with this as it fills. And so the height of water above it is going to increase. Yeah. I think I see how this is going to work. Yeah, exactly. Changing the height or something. Yeah. I agree. Yeah. Let me think, sorry. Yeah, it's kind of interesting. Is it H minus H? Yeah. Let's call this little h. I'm just going to call this little h, just for now. I'm going to say that little h is the amount. This is the water in the boat. The height of water in the boat, okay? Because as this thing sinks, right? Let's say, for instance, it sinks down to here. Okay. Then the new hole where's my circle? Then the new hole is down here. But the height of this water is still like 1 meter. Relative to like this surface. But now this has what is this, H2 above it. Or, ooh, okay. If we call this 0 and we say this is like H, big H plus little h, right? Yeah, that's another way to think about it. Yeah, okay. Let's see if this works. And then there's another row here, right? Row GH. Okay. All the rows cancel, which is nice. Let's just see if this works. We're going to have a G left over. Okay. But I'm going to get that. So G minus GH is equal to 1/2 V2 squared. Okay. So then 2G 1 minus H is equal to V2 squared. So then V2 is equal to the square root of 2g 1 minus h. And let's see if this makes sense. So in the case that the height of the water is equal to 1, right? This whole thing goes to 0, right? So once this thing sinks so far down that you have a full meter of water in it, now the velocity won't be anything greater than 0, right? The velocity won't be non-zero. The water velocity only exists because it wants to like come into like an open cavity here. Once this is filled up to a meter, then it's completely sunk, and now you don't have any more water. You don't have any more velocity water going into it. Okay, I think I see this. I think another way maybe would be to have called yeah, the g minus gh. Well, that just comes from moving this over to here. This is 1 times g, so that's just g, and then we just minus gh. I'm trying to make this make sense though, like with a coordinate system. That makes sense. Because it's about like measuring where you have to measure h from like a common datum. You have to measure the height from the same position all the time. So I'm trying to think here. Yeah. What if I call, let's maybe call this height 0? Let's think about this. If I call this height equal to 0, and then that means that, let's call this like h1. That means h2 would be equal to -1, right? And then as more water fills into it, like more water h, let's just call it like little h. As more water fills into it, this thing should move down. So I think this is this -1 minus h then? The issue is I need when this is 1, I need the pressure to go to 0 for it. Not to -2. Yeah, this is tricky. Because basically, yeah, I want when this thing hits a meter, I need this pressure term to equal this pressure term, right? And if I'm setting this equal to 0, this needs to be like -1 plus h. I want to know, like, why it's going to be -1 plus h, though. Yeah, the issue is because now you're going to have water above you as well. One sec. Let me look at it. Let me think. Oh, okay. I think I get it. Okay. Oh. Okay, cool. I got it. I figured it out. Yeah, okay. So, this is a simplification they make. Apparently, it's called the leaky tank problem. Okay. We assume that as this thing fills with water, it does not move down. Yeah. I thought it would, but apparently we don't. Apparently, because this is only like 5 centimeters, which is very small compared to like how far below the thing is, right, from the water line. Here's what we're doing. I got it. I see what's happening there. I thought for sure that the hole must be moving down as this sinks. But I guess because this is it is annoying in physics when this happens, but we just start neglecting things. In the same way that I neglected, right, that there's any velocity of the water outside the boat, because the water level outside the boat is not changing that much because it's such a massive body of water. We also assume that the height of the hole does not change as it fills up with water. All that happens is you have another layer of water on top, which is now creating pressure downwards. Okay, so scrap my idea of the hole moving downwards. Okay. The hole stays the same. Otherwise, yeah, we would have to start looking at like buoyancy issues. with like how much the thing sinks. But let's assume it's constant, okay? So here, I'm going to call this H is equal to 0. So here, big H is equal to 1, okay? Or here, we can say like H1 equals 1, H2 equals 0, okay? And this does not move. So I'm going to leave that as it is, okay? And then this I'm going to get rid of, but I'm going to show you what happens. So here, let's get rid of this. So this goes away. However, okay, as if we're looking at what the base pressure is here. So outside you have P atmospheric. Inside the boat, you're going to have P atmospheric plus rho g h, where this h is the height of the water in the boat. Okay? So think about you have, right? Yeah, some like layer of water in the boat. That's going to create a downwards pressure, which we know is equal to rho gh. Where this is the height of the water in the boat. Okay? So when this is 0, right? When the boat is bone dry and like there's no water in the boat, this goes away. Okay? And that's when velocity is going to be the most, right? But as this gets bigger, okay, now this is going to start going down. And that should make sense because eventually this will just equal this, the 1 meter, and then the thing will stop sinking. Like there's no more pressure to put it in. Okay. What's up, Reki? Does that make sense, Mistral? So key thing is here, we're setting this as like 0. And then what's happening is this thing is slowly filling up with water. And as it fills up with water, this P2 term here is going to include the pressure of the water that has gotten into the boat and is, you know, pushing down on it. Let me make sure Mistral gets that. Sorry. I know, it's been a lot. I'm going to start doing some of the math. We got to do calculus for this. That sucks. I'll show you. We'll get rid of this. Okay. I'll show you. So this is going to be rho g times 1. Okay. This is going to be equal to... So let's put all the terms in. All right. So watch. I got P atmospheric, right? Plus rho g times 1. Okay. Because that's the height of the water outside the boat. And we're going to say that is always 1 meter away from the hole. We're going to say the hole has a height, is at h equals 0. Okay. P2. That's P atmospheric. This is like background pressure. So you have the background pressure of the atmosphere, but you also have the pressure of the water that has been filled into the boat. And so that's plus rho gh. And then this is plus 1/2 rho v2 squared. And then this term is 0 because we're saying at where the hole is, that height is 0. So watch what happens. Some things are going to cancel here, right? This cancels with this. And I end up getting like, right, rho g is equal to rho gh plus 1/2 rho v2 squared. Now, as this is the height of the water in the boat, as this height of the water in the boat goes up to 1, now this equals this, so this will be 0. And that should make sense Because once you have a meter of water filling the boat, now you no longer have any reason for water to be pushed into the boat. Can I repeat that part? Ooh, you got to say which part. If you say that part, I don't know what that part means. Because, yeah, there is like a 5-second delay on YouTube. Okay, row GH. Okay. So, this is the, like, background pressure. Okay. Which here is going to be P atmospheric. Right? You have atmospheric pressure pushing down inside the boat. And then you also have the pressure of the layer of water that has entered the boat. And that's rho G little h, where little h is the height of the water in the boat. Okay? So that's why this is all like background pressure. You have pressure from the atmosphere, and you have pressure from the water above the hole, because that water has made it into the boat. Now, when you do the math here, right? When I, bring this down, cancel this with this, I get this, okay? This is a typical, conservation of energy, conservation of pressure, whatever. Left side has to equal the right side, okay? This is going to vary, right? This will vary. This will vary as water fills in the boat, okay? And what I wanted to show, right, is that when the water in the boat is 0, right, when there's no height of water in the boat, okay, now this is going to have to be the biggest it can in order to equal this. As H gets bigger, as the height of the water in the boat, like the amount of water in the boat gets bigger and bigger and bigger, okay, as this gets bigger, this will now become less because it doesn't need to add up to as much in order to get to this total. Think of it like this is like 5, right? If this is 0, then this is 5. But as this goes up, let's say this is like 4. Now this is going to go down to being only 1 in order for like these two things to equal this thing. So as the height of water in the boat goes up, eventually this height will equal 1. And when that happens, you have rho G equals rho G. So this must be 0. So the physical meaning of that Mistral is that, like, as the height of the water inside the boat eventually reaches the 1 meter line, now the boat is in equilibrium and there shouldn't be any more water flowing into the boat. There's no need for it. Technically, we have to do like another analysis to make sure like there's enough buoyancy for this thing to stay upright and whatnot. But we're not worried about that. We're just getting to this. We're just trying to figure out how long it takes for in this case, not even a meter, for like 5 centimeters of water to fill. So we're not even concerned about it getting all the way up to a meter. Is that good so far? I was getting confused with this like H2 because I thought that the hole was moving down. Apparently the hole doesn't. You consider the hole to be stationary. Okay. All right. So if this is what we have so far, I can also cancel out the rows, right? These all go away. Sib says a bit. Yeah, it's pretty tricky. Okay, so now this cancels out, right? And I have G minus GH is equal to 1/2 V2 squared. Okay. So 2G 1 minus H square rooted is equal to V2. Does that make sense so far? That's the velocity of the water as it sinks, or as it fills with water. As the boat fills with water, that's the velocity of the water entering the boat. And this makes sense because when the height of water in the boat is 1, now the velocity is 0. So there shouldn't be any more water getting into the boat. Okay. So now that we have like a velocity of water entering the boat, I can convert that water into like a flux, like a volume, right? So this is called like the volume flow. Volume flow, which is going to be equal to like surface area times velocity, right? So if you have, for instance, right, a surface area of water, and you want to figure out how much volume is like flowing into there, right? This would be this times dx dt, right? Dx dt would then give you dv dt. So the amount of the rate at which the volume of water is entering something is equal to the surface area of that water times how fast that surface area is moving in. And that's dx dt, right? It's like you have like a bunch of little slivers of surface area, and you're like, okay, well, how many of these surface areas can I like throw into to wherever I need to put the water? And in this case, it's because I'm trying to put the water in here. So I can come up, which this is called like I guess like flow, flux, volumetric inflow. Yeah, volume flow is what I call it. They call it Q. This is volume flow, which is the same thing as dv dt. And that's equal to the surface area times V2. Okay? Which, in this case, the surface area of the hole, right, is pi times... How big is the hole? 1 centimeter. Oh. Times 0.01 squared. All right. And then that's times the square root of 2g 1 minus h. And this is equal to dv dt. Okay. Now another cool thing. So maybe you did this in calculus with like related rates, right? The amount of dv dt that's flowing in is also the dv dt that is like rising inside the boat. And so this is also equal to the surface area of the boat times dh dt. So we can think about this as right? This is flux into boat. And then this is like flux of water inside the boat. So the amount of volume that's going into the boat is the amount of volume that is in the rising water level that's inside the boat. Does that make sense? I think we've done that in related rates before, right? You have like something like this, and you have like a hose, which has like dv dt, and then that is also equal to like this, which is like area dh dt. So like the volume of this going up is the same as the volume of liquid from the hose like pouring into the tank. Good, Mistral, or not? Let me know. It's confusing. Don't worry if it's difficult. So key thing, this is surface area of the hole. And then this is surface area of the boat. You can expect something kind of similar. Not this tricky. This is tricky. I don't think I'm going to make you, like, integrate. Because the issue is that, yeah, the height of the water above is... So, like, the flow rate is changing with time. This is pretty tricky. Unless you've done it in discussion. I have to check through discussion. That's my next step today, is to see what you guys have done in discussion. If you've done this in discussion, then yes, it could be on the test. I haven't been the best at, like, keeping up with what he's doing during discussion, because he's usually a couple lessons behind, and again, this class is so fast, I get, like, no break. Every day I teach something, I then immediately have to go figure out everything I'm teaching the next day. There's no rest. It's just constant. I understand why people don't teach during the summer. It's fucking brutal. It's a constant onslaught of, like, okay, and then this, and then this, and then this, and then this, and then this. Just keeps hitting you. Okay. Let's try to get this. I'm pretty sure we can get this. Because this is going to become a related rates question is what it is. So here, let me just call this whole... I'm just going to leave things as, like, simple variables. I'm going to call this A. I'm going to call this, like, big A. Okay? So I have A square root of 2g 1 minus h is equal to big A dh dt. Oh, okay. Well, he hasn't seen my test, so he has no clue how hard it is. But he taught this last quarter, so he's probably basing it off of what the last professor did, which I do have their tests as well, so I'll look at theirs just to make sure we're not going crazy. But discussion is usually a little bit harder, yeah. Yeah. All right. Hell no, related rates. Yeah, it is. Yeah, bro, this is why. Yeah, it's all connected, dude. It's all connected.
You gotta get in the hospital.
Where's
Obviously, don't go and do that, please.
Do you have to go do it?
like.
You have
We
to, dude.
can't condone anything of the sort.
We can't live.
You gotta live and do some related rates, man. Okay. So watch what happens. Because I want to solve for t, right? This is the... I know it looks scary. But we're just looking for this bitch, right? I'm just trying to figure out, like, how long it takes, dt. So let me put dt over here. Let's put all this other stuff over here. So I'm going to say dt is equal to a over little a. And then it's dh over square root of 2g 1 minus h. Okay. And now we can integrate both sides. And we're going to integrate from, like, 0. So I'm going to say, like, t final. And then in here, in terms of the height, right? That's integrating from the height going from 0 to 0.05. Right? Because that's where I want to figure out. I want to figure out how much time it takes for this little h, the height of water in the boat, to go up to 0.05 or 5 centimeters. Okay. So this is easy. Integral of this is just TF. Cool. Awesome. And then this is going to be big A over little a. This integral... Is this an easy integral? Is this fucking integration by parts? I'm gonna get so mad if it is. Actually, it's not that bad. Yeah, what am I saying? Yeah, wait. Yeah, okay, this isn't that bad. I say it's not that bad. This is U sub. Okay. U sub. So you say U is equal to 2g 1 minus h. And then du is going to be equal to negative 2g dh. Okay? Because if I multiply that out and then take a derivative, the derivative of negative h is just negative 1. And then it's negative, right, times the 2g, so it's negative 2dh. Okay. Cool. So I can rewrite this integral. Don't worry about my bounds yet. I'm just going to do it. So this means that dh is equal to du over negative 2g. So we have du negative 2g, and then it's the square root. This is all u now, right? Square root of u. This is actually not a bad integral to do, right? Because this is the same thing as the integral of 1 over negative 2g u to the negative 1/2 du. Raise the power, divide by the new power. So negative 1/2 jumps up to positive 1/2, and then we divide by 1/2, so that's a 2. So I get 1 over negative 2g, and then that's going to be 2 u to the 1/2. So cool, 2's cancel. And I'm left with just negative 1 over g square root of 2g 1 minus h, right? Because that's what u was. Okay, so all this goes over here. Mistral's like, just fucking make it stop, dog. Stop. I mean, this is why this is also like a bonus practice question. Maybe I'll put this on a bonus. This is actually kind of fun. I think it's cool. I agree. It's very unfair to like to ask you to do something like this. But oh, and then this is from, sorry, my bad, from 0 to 0.05. Okay, so we have to do this, and then this is negative 1 over g square root, I forgot we still have bounds, 2g 1 minus h, and then this is from 0 to 0.05. Okay, so TF is equal to, with the negative, I'm just going to switch the order that I do the bounds. I'm going to do this one first. So that's going to be a over little a g square root, we're plugging in for h, right? It was dh? Yeah, it was dh. Okay. So square root of 2g minus square root of 2g times 1 minus 0.05. Okay. Let's plug all our variables in. Big A is 50 meters squared. So that's 50 pi times 0.01 squared times 9.8 all times the square root of 19.6 minus the square root of 19.6 times 0.95. Let's see what we get. You think we're gonna get the right answer? If we get 30, I'll I don't know. I'll make like a big celebration or something if we do it. Let's see. Because the answer is supposed to be 30, right? Okay, so 50. Actually, let me do the square roots first. So square root of 19. Yes, we're still in the sinking barge problem. It's a difficult one. But I mean, bro, yeah, what? This has taken us an hour. Obviously, I could not ask this on like an exam. Because I'm not going to ask you an hour-long question. Okay, there we go. We get that. Times 50. Divided by pi. Divided by 9.8. Divided by 0.01 squared. 1820. That's not 30. Oh, this is in seconds. Wait a minute. Aha. This is seconds, right? All right, let's divide this by 60. Yo, 30.34 minutes? What? Yes. Dude, Lil Yachty coming out for that one, dude.
That's super cool.
Wow. I'm very proud of you guys. Yeah, this was kind of a bitch. Yeah. Okay, so there you go. Yeah, that's how you do the sinking barge. That's how you do it, man. Painful, thanks. I gotta go now. You're okay. I'm not gonna ask this on an exam. If I did, I might like put it as like a bonus question, just to like see who's using ChatGPT, because none of you should be able to do this. So the people that could do this, I'd be like, I know where you got the answer from. Oh man. Nico says, how to explain to my parents that I'm at office hours with Little Yachty on the stage? I don't know. Do you have to explain to them? Does it need an explanation? Jeff says, can you do anything about my sinking interest in this stream? Punny Jeff. Good one, Jeff. Yeah, right? Yeah, the electricity stuff is cool. This is... Fluid dynamics is pretty painful, man. Right? Yeah, fluid dynamics, like... I'll be real with y'all. I didn't really do much fluid dynamics, like, anywhere in my undergraduate. It was barely covered in undergraduate. I don't think I ever really covered fluids in like my undergraduate education. I don't think I ever took fluids. And you definitely didn't take it in grad school. So E&M I like. I did a lot of E&M. Yeah. Yeah, the fluid stuff is the hardest. I think I don't know if it's the hardest. It's the most foreign for sure, because it's not really seen very... I mean, this isn't like difficult. Once you get the setup was the most difficult. I was struggling so much with trying to remember if like the boat sinks, if like the hull moves downwards as it fills with water, which I thought it would. And then I thought I have like another like derivative I have to deal with. But then there are these approximations where you're like, oh, well, just assume the boat doesn't really sink that much. And I'm like, okay, bro. Once you get to this part, once it's the math, this is not so bad. Well, you also have to know about volume flow. Okay. But okay, once you get to here, this is a beautiful separable differential equation, or like related rates. Yeah. What did you mainly associate with? I mainly liked E&M. I did a lot of E&M in undergrad. And then obviously when I went to grad school, I studied plasma physics. So plasma physics is like E&M on steroids. You start dealing with all sorts of weird electric and magnetic field configurations, and you're trying to like solve for weird forces and like there's a decent amount of waves. There's a decent amount of waves in plasma physics, but it's like electromagnetic waves, or like I guess there are some fluid flow waves, but we don't really use the Bernoulli equation so much. So yeah, fluids is I enjoy teaching it at this point because it's foreign to me in a sense, and so I'm kind of learning alongside you guys with some of these harder problems for sure. Easier stuff, yeah. I mean, I know how to like calculate rho GH and P equals F over A. I mean, that's easy stuff. It's the weird situations of like the boat sinking and then like there's a hole, like that stuff to me I haven't really seen. I don't think many other physics professors have seen, honestly. Guy says, do I know a thing or two about quantum? I do a little bit. I enjoy quantum. But, yeah, okay, good, yeah. You're very welcome, Sib. Yeah. Bro, someone posted this question. Dog, I've done this question so many times. This is the stereotypical, what is it? The stereotypical, like, impossible geometry question, because it looks easy. Right? Yeah, dude, to the fucking people that send me this one, it looks easy, right? Because you're like, oh, wow, well, then this must be 70 degrees, and this is 70 degrees. And then, oh, man, yeah, we just need to, like, get this, and then we can get... It looks... If you try to go the usual method of just, like, grinding through angles and, like, setting variables, it becomes, like, this endless loop. The solution for this... Yes, what's up, Zach? Shout out to Zach, by the way, for doing the impossible, and solving 100. I know you said it was 93, but 100 integrals yesterday, dude. That was fucking dope.
That's dope.
Yeah, Zach's the integral man, dude. If you have, we were doing baby integrals today, Zach. We were just doing like some. This is a pretty baby integral, solving for h. But yeah, this is a classic question, and the solution for this is actually like 10 minutes long. It's not very easy. I think it also involves drawing like another line, which I hate. I hate geometry questions where the solution is to like draw new lines in or draw new angles in. Because I'm like, bro, why did you just put it on the diagram to start with? Like, how am I supposed to like think of it that way? Yeah, impossible geometry. Yeah, this is a classic. I'm not gonna do this. I've done it so many times. I'll send you the link for it. Yes, the dreaded auxiliary line. Zach knows what I'm talking about. We hate that. I hate geometry questions where you have to create like new lines. Like what? Anyways. Shantrix. Oh, are you typing your questions now, Shantrix, in? Let me see. We probably got some stuff in the screenshots. Reki has a couple too. There's a ladder on the side to a ship of water. The ladder dangles just above the water. There are 10 rungs on the ladder, with each rung being spaced a meter apart, and the last rung touching the water. If the water tides rise by 5 meters, how many rungs will be under the water? Is it the same? Doesn't the ship rise with the tides as well? Isn't that a trick question? Yeah, right? Yeah, that's a trick question, right? Yeah, I mean, the boat doesn't start sinking more. Random question, what integrals do I know? I mean, I know all the basic calculus ones. If again, Zach, e to the 2i pi, he's the integral master. He was doing like measure theory integrals, like integrals I didn't even know you could do. He's like doing integrals in like other math disciplines. I think like the hardest thing I know for integration is probably, what would it probably be? I don't know, like trig substitution is kind of messy, kind of a pain. Integration by parts, or I don't know, partial fractions, that's another one. Or when you do, if you do integration by parts and it's like cyclical, that's a cool one. Zach, did you have any cyclical integration by parts during your 100 integral stream? Power series, yeah, that's just like you just change the number on like the indice or something. You did at least one. Cool, Zach. Yeah, I love the cyclical integration by parts. Those are always really, really fun. It's like you do it and you're like, oh, I have my original thing. It's like, oh, nice. Yeah, those are cool integrals. I guess I have done some complex integrals, like the pole stuff. Yeah, indices. Yeah, that's what you do for series. With series integration, I think you just like move the indices and like change like some exponents or something. Volume integrals can get tricky for sure. Surface integrals. Anything Green's theorem, Stokes theorem, that's up there with like difficult integration. It's like a matrix. Maybe you could integrate matrices as well. I don't know. What about lines? Line integrals? Yeah, I've done line integrals. Yeah. Or like you mean like parameterized to a line type integrals? Yeah, there's like line integrals, path integrals, surface integrals, volume integrals. All cool little things. Reki says, is it my question? Yes, we'll do yours next. 1K says, how many achievements should I put on my resume? Ooh, good question. Depends how old you are and what you're applying for. So I would say if you're in your like mid 20s or upper 20s and you're applying to like jobs, you don't need to put down like your high school achievements. They don't really care that you got like, I don't know, honor roll in like high school, or I don't know, we're spelling bee champion. I mean, maybe spelling bee champion is cool. You should put achievements that seem related to the job that you're applying for. So, if you're applying for something that involves a lot of people skills, then yeah, maybe if you were on debate team and you did really well in debate and that was an achievement in high school, I would put that down for sure, you know? My 6th grade math competitions don't count.
Disqualified.
No, unfortunately. You know, the one thing I still put from high school is that I'm an Eagle Scout. I do that, yeah. I still put that on my resume. I put Eagle Scout. Yes, Raven, I am still doing problems. I'm just taking a break from... Did we spend an hour on this this fluid dynamics question? We just did. We got the right answer, though. I was really happy about that. Yeah, Zach, did you ever... I really like Boy Scouts. You know, minus all, like, the kid raping stuff, but when I have children, I'm definitely putting them through Boy Scouts because I think it's very important for kids to go outdoors. And, like, I learned a lot by just being in the wilderness, and a lot of that is because Boy Scouts forces you to do that. You have to go out and, like, camporees and, like, hiking things. I did one thing when I was in high school. I think I was, like, 16, where we were in the middle of New Mexico for, like, it's called Philmont. It's a really famous hiking ranch, but we were there for 2 weeks with just, like, a couple of, like, 1 or 2 adults, and we had to, like, backpack close to, I want to say, like, 90 miles between places, like, carrying our food. That was, like, a really cool experience. It was pretty grueling. It's pretty tough at times, but I think stuff like that's awesome. Didn't Boy Scouts go bankrupt? Probably. I'm sure someone bought it out and it still exists. I don't think Boy Scouts is gone. I think they tried to do something where they're opening it to all the genders, which they already do. That's called Venture Scouts. But I don't know. Just whatever. Nico says, just wanted to check in. What's the cutoff for topics on the exam? So the exam on Friday will cover everything up to E&M. So not including E&M. So like sound, waves, periodic motion, fluid dynamics, all that stuff is like fair game. But yeah, so I think it's like week 1 and week 2, Nico, is what's good. Not week 3. Oh, they filed for bankruptcy and now they're getting out of it. Nice. Reki, what's up? You want to do your question? You teach and you stream. Yeah, I mean, if you want to watch, I stream my lectures on YouTube as well, but those are at like 12:30 in the afternoon. They're like earlier. This is kind of like my office hours where I help out people with like whatever stuff. You're welcome, Nico. Yeah, if you want to check it out. You're following my YouTube, right? Yeah, just go to my YouTube page. You can literally, if you go to like YouTube. Yeah, bankruptcy is not the end. You know, bankruptcy is a way to reorganize your debt to like keep going forward. I think it's like the difference between like chapter 11, chapter 12 or something. But yeah, so if you go to live here, you can see like when I have lecture streams and then when I do like my office hour streams. And so these are all, it's free, available, open. You have to pay UCLA if you want a degree from learning from me. One more question. Do you ever plan on streaming Marvel Rivals? I actually have never played Marvel Rivals. I'm hesitant to learn a new game at this point because I have something like 300 hours logged on the finals, and I don't want something else to consume my entire life. I don't have time for anything at this point. But I am going to play some Fortnite with the students of our server on Saturday. It's part of this summer camp we're doing. It's called like virtual summer camp. Here, if you go to like summercamp.actual.education. Did I get that domain to work? No? Okay, whatever. Actualeducation.net. Those are rookie numbers, dude. Yeah. Or if you go to, yeah, here we go. We have like a virtual summer camp. That Kudu's being really nice. They're sponsoring. So yeah, there you go. And we're giving out like a Nintendo Switch too. But basically, like, you play video games, you can come to office hours and ask questions, get credit, and then we're also going to do like some math quizzes throughout the summer, just to like keep kids engaged with math while like summer learning loss happens. You asked a dumb question? No, there's no such thing as dumb questions, E-Raven. Yes, we will do Roblox for sure. Yeah, we're going to do Roblox the following week. I'm going to do Fortnite this week. just because it's easy and I know it. And then Roblox, I was testing out some games with some other people. We might do like Doors or something. I gotta figure it out. I've never seen a teacher like you. Wow, I'm pretty unique. Thank you. I think we're gonna do trios 1K. I like, well, it's like duos. It's like you two are a duo, but I'm like the trio. Yeah. You did? Okay, cool. Reki, let me help you with this one real quick. Determine the non-permissible values of x and radians for each expression. Okay.
Nice.
So let's look at this one. We got, wow, thanks for the follow, Pavermi. Cosine of x over sine of x. Okay. This is cool. Do you know what, like, not permissible is? Like, not allowed? Like, you'll break stuff, you're not allowed to do it. Ooh, wow, you got surface integrals, Raven? Ooh, this is gonna be fun. What is it, Reki, then? Yeah, the denominator can't be 0. Right, yeah. Yeah. So, yeah. Denominator cannot equal 0.
No.
Exactly, good. So you basically just look for where the denominator is 0. So in this case, you're gonna ask yourself, where does sine of x equal 0? Right? And sine of x equals 0 at 2 places. Well, actually, like, infinite number of places, but within 2 pi, it's 2 places. So sine of 0 is 0 at 0. And it's also 0 at pi. And then, like, 2 pi, and then 3 pi, then 4 pi. Was sine of x equal... Yeah, so that's a good question. And I think that's what's going to happen, Jeff, when we get to this. So, yes. So, for this one, it's like x cannot equal n pi. You can't have 0 pi, you can't have 1 pi, you can't have 2 pi. And then you say for, I don't know, n equals 1, 2, ... Okay. So then... And negative numbers? Yes. Okay, so am I supposed to write it this way? Is you guys do this like this fancy thing? Is that what it is? And it's all natural numbers? Any whole number of pi integers. Yeah. This is only positive numbers? Is this really? Is that how it works? Oh, z are the integers. Okay, there we go. Is it something fancy like this? They always put like these weird like script things on it. Okay. Okay, so this is interesting. Sine of x over tangent of x. So because sine of x, tangent is the same thing as sine over cosine. Ooh, thank you, Zach. Look how pretty that is. Zach wrote it out exactly correctly, dude. Can I exactly correctly? That's a pretty good one. Zach wrote it exactly correctly. He's like, okay. Okay. So this is the correct thing. Yeah. N is contained. Yeah, not n is equal to. Yeah, sorry. N is contained. N is contained in Z. Okay, but here's the weird one. Because this is sine of x over tan x. Tangent is the same thing as sine over cosine. Right? So this is the same thing as sine over cosine. So here's my question. This should cancel to become just cosine of x, right? And then any number of x is permissible. But as the expression stands, I think tangent of x still can't be 0. Is a member of different than within the domain of? Ooh, good question. I do not know. A citizen of the integers? What? I'll let Jeff or Zach answer that. They're the more higher level math people. I tend to just be like, it's good enough. I don't get caught up on the definitions but I know that there's extreme differences about being particular. I'm always just like, whatever, like n's an integer. Is it a member of within the domain of? To me, it's kind of the same thing, but maybe it's different. Integrites. Yeah. He's got some good ones. Okay, but yeah, for this one, for B, I think you have to take it as it stands. I think it's a removable discontinuity, is what we call it, right? Because when sine of x is equal to 0, you'll remove that discontinuity by canceling, but if you plug it straight in, it's not going to make nice things. A member of is for a set, and within the domain is also an element of a set, so I think it tracks. Okay, cool. Yeah, make sure, go follow Zach. Zach's great. Zach's got a great math stream. And he also streams pretty regularly. You were on earlier today, Zach, I think. For those that don't know, we have a calendar. Oh, that's my personal calendar. You don't want that. If you go here. Hi-yo, I've been lost somewhere. Yeah, here's like the calendar for like streams. Zach, I could have sworn you were streaming earlier today. But anyway, Zach has a stream on Saturday as well if you want to go check him out. Okay, so yesterday happened. Yesterday did happen. That was a lot. Okay, so technically, even though this is removable here, Reki, you have to say it's still not okay for tangent of x to equal 0. So you can't have n pi as well, right? And then it's for this. There you go. What's up, sup? So x over x is not equal to 1 as functions. Yes. What if yesterday's still happening? This is a dream. Wake up, guys. Wake up. Okay. And then for this one, sine of x cannot equal 0. And then wait, cotangent is cosine of sine. Oh, okay. This is cosine over sine. So it's like doubly, right? You really can't have sine being equal. Oh, wait, so your sine of x can't equal 1 from here. But then from here, I believe sine of x can equal to 0. Yeah, 1 minus sine of x. Yeah. 2-week holiday. Nice, dude. I'm going to have like a month-long holiday / be unemployed once like August hits. So I think there's 2 conditions on C, right? So because cotangent is equal to cosine over sine, and cotangent isn't defined, so this cannot equal 0. Da-da-da-da. Yeah, so for the sine of x to be 0, right? That's not permissible when it's n pi. And then the other one is when it's pi over 2. So yeah, it's all pi over 2. All pi over 2, yeah. So for x is equal to n pi over 2. N is contained in that. There you go. Yeah, that makes sense. Yeah, because the whole number pi's is what makes sine equal to 0. And then the half, the pi over 2's, like pi over 2, 3 pi over 2, 5 over pi over 2, they make sine, or sorry, it's equal to 1, not negative 1. Yeah, sine of x can equal negative 1. Ooh, never mind.
That's dope.
I fucked up here. I make mistakes sometimes. It happens. Yeah. Yeah, so x equals n pi, and then x is equal to pi over 2 plus 2n pi. Yeah, that's what it is. Yeah, sorry. You can have sine of x equal negative 1. Yes. Oh, Dr. Gold's awesome as well. Yeah, I can help you out, Sup, if you want to submit a screenshot. I'll go through it. I got to do Ravens next. Okay, and then for this one, This is cosine of x cannot equal 0. And then also cosine of x cannot equal -1. So this will knock out the 2m plus 1 over 2 pi, right? That's where you get the pi over 2, 3 pi over 2, blah, 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 blah. And then this will be negative pi plus 2 pi n. Yeah. So like that or whatever. And then like, I guess we could also just say pi plus 2 pi n. That works too. Yeah, okay, cool. Good job, Reiki. That's a fun question. So yeah, if you have yeah, you're welcome, dude. If you have a question, sup, and I'm like, I'm not around, or, you know, we're not streaming, or anything, we have a Discord. I guess, is it called like a forum thread or something? I think it's called like a forum thread. But yeah, there's like a little channel here called Homework Help, and you can just like post whatever homework questions you have, and then when I have like free time or other people have free time, like for instance, I think here, yeah, someone was like responding. There are other experts that lurk around in my server, and they'll help you out as well. Okay, so let's see what Raven has. Oh shit, then I gotta go teach. Ooh, okay. Ugh, I got another student I gotta tutor today. Non-stop. Ooh, Enchantrix, you got a good one. Wow. Okay, I'll see if I got time for that Enchantrix. Yes. He was streaming for 10 hours yesterday. Zach gets a streaming break. Saturday, yeah. Yeah. Okay, what is... I just need explanation. No need to solve the problem. Okay. S is the part of the cone surface inside the cylinder. Oh, okay, I get it. So this is one of these. And wait, is the cone offset? No, the cone's in the center, right? Or is the cylinder offset? I feel like the cylinder's offset. Where's the cone is centered, yeah. I feel like the cylinder is offset, or oh no. I don't you got this diameter with radius. It's okay, it happens, bro. Near the polar coordinates. This is a standard cylinder, right? Rho cosine theta, rho sine theta. I assume this is Z. Z is just some constant R, yeah, right? Or, well, wait, what? They're cylindrical coordinates, I think. Are these polar? I think is this polar? It is I. What is I? Okay. And then this is what you're having to integrate. xy plus yz plus zx equals ds. Man, why does this remind me of like some like Green's theorem thing? You know when you do like one with one, it's like you do the round robin of the coordinates with each other. Yeah, z is just height above the xy plane. Yeah. Wow. Okay, wait. What class is this? Summer camp just started on Monday. WHZ. This is math 2. This is complicated. I love when like math subjects become they just have like simple names. They're like, "Oh yeah, it's just numbers." Or it's just algebra. Yeah, the equation of the cylinder. I see some like S equals Z equals square root of x squared plus y squared. Yes. X minus a squared plus y squared is equal to a squared. Ah, okay. So it is shifted. It's shifted by x. I see. It's a symmetric sum, yeah. So they're saying that you have like this. And then... yeah. What? This is like A. And then this is kind of like the cylinder. Let's see if I can like draw it. Nope. I'm trying to draw it. It's kind of weird. But it's, yeah, but it's on that corner, yeah. Okay, alright, I'm gonna stop messing with it. I think this is what we have. I don't know what the equation of the cone is, but it might be that the only place of overlap is between negative pi over 2 and pi over 2 in terms of theta. And also, wait, I always got to ask, like, where is theta measured from? Is that from the x-axis or the y-axis? Or, wait, that's the phi that gets measured in weird places, right? Between math and physics? I don't think it's theta. I think theta is always measured from the x-axis. Theta is the azimuth angle? Yeah, okay. Yeah, azimuth makes sense. Okay. God measures phi from the xy plane. Physicists measure it from the z-axis. Yeah, right? Physics does it different. Z equals the square root of x squared plus y squared is the cone. Okay, that makes sense, right? That's why it's circular. Right? Because you have basically like... okay, so let's write some stuff. Okay, so cone. Z equals the square root of x squared plus y squared. And then the cylinder is... I think we had it up here earlier. Let me get it from Raven. X minus a squared plus y squared is equal to a squared. Okay. So that's a cylinder of radius a that is shifted to the right on the x-axis by a. Okay. I see. Okay. So this distance right here is A. And so if we look at it from the top, let me look at it from the top real quick. Yeah. So this is like top view. Where this is Y, this is X, right? Then this is the cylinder. And then the cone is going to look like a bunch of like smaller ones of these, right? As it like gets bigger. Right? And so this is the cone, which is equal to what, x squared plus y squared is equal to z squared, basically. Okay. So the overlap, this will eventually overlap, right? When this has a radius that's equal to a, right? Like eventually the cross section of your cone will intersect with just z. Oh, sorry, x squared plus y squared is equal to z. Oh, is it? No, you said z was equal to the square root of x squared plus y squared. Did you not? So that means x squared plus y squared is equal to z. Z squared, right? Okay, that's fine. Okay. So yeah, what I'm saying is that, like, this is, for instance, like, z equals, I don't know, like, 1. Or let's just say, like, z is much less than 1. Or z is much less than a. Okay, cool. This is z is less than a. Because then the cylinder is x minus a squared plus y squared is equal to a squared. The width of the circle has to decrease linearly. No, otherwise it's not a cone. I think it's okay. Okay, so then you have this special case here. Here, let's make a special blue one here. When this is equal to a. Okay, so here's where you have x squared plus, this is where z squared is equal to a squared, right? Z is equal to a. Yeah, okay, this makes sense, right? Because then x squared plus y squared is r squared, and radius is now, oh, equal to 2a, actually. Sorry, my bad. Wait a minute. Or square root of 2a. Right, because this distance here is equal to a. Okay. So when z is equal to the square root of 2a. Because then you get x squared plus y squared is equal to r squared. No. Z is equal to 2a. I need to stop being chill. Okay, this is 2a. Okay. (2ax). Wait, there's 2ax. Okay. This is z is equal to a, actually, right? Okay, Zach is saying r equals 2a cosine theta. Traces out concentric circles if theta goes from 0. Oh, okay. Well, sorry, theta goes from 0 to 2 pi. Right, yeah, oh, sorry. Yeah, okay. Wait, r equals 2a. Oh, okay. Theta traces out the arcs of intersection. Okay, he's talking about this. Are you talking about like from here to here, Zach? Which, yes, eventually... Uh-huh, okay. Yes, R equals 2. Traces out a circle. R equals... Oh, if R equals 2 cosine theta... is the max radius of a circle. Which, the light blue circle? The light blue or the solid blue? I realize I fucked up by making them both blue. The light blue circle, yeah, okay. Okay. So that tells us our maximum Z as well, right? I think our maximum Z is then 2A, no? Because that's when the light blue circle will hit the border of the cylinder. Exactly, right? It only intersects at a point, right here. Right. And 2A cosine pi over 2 and 2A cosine negative pi over 2 is 0 anyways. Okay. So, I guess this is correct then, right? So you convert the XY stuff to whatever coordinate system you need. And then dy goes from... Is it really... This isn't dy anymore though. No, right? This should be r dr d theta, right? Yeah, okay. Does this make sense, Raven? From this like picture of like what we have? I think like doing the top-down view kind of makes a little bit more sense. You glitch sometimes. It's all good. It happens. I glitch. Okay, nice, cool. Very cool question. I liked it. Yeah, top down is very key for doing polar. What's up, Equity? What's crack-a-lackin'? I was gonna end my stream, but I'll keep answering stuff. What's up? Oh, I think Shantrix has one too. So let me go find Shantrix's. Oh, I killed my music. Oopsies. My music. Get my music back. You're busy on Monday? That's okay, dude. It's okay to be busy.
Imagine being able to build anything.
Imagine being able to build anything. Here we go. Quick question. Could you code up Dijkstra's algorithm in Julia? No.
No. Surprise, motherfucker.
What? Excuse me? What is that? Alright. Here, let me see if I can do Shantrix's. Or actually, Equity here. You did ask yours yesterday, and I didn't get to yours. Let me do yours first, real quick. Which one do you want help with, Equity? I don't know if I have time to go through everything here, but what's like the hardest thing? And then Shantrix will do yours, and yours will be the last for today. Because I'm also roasting. My studio has now hit 85.4 degrees. I should get like a digital thermometer to put on the stream here, so you can see like how much Dr. Gold is roasting inside of his master closet. It's gonna start getting hot with the summer, I can tell. No AC. I have like an AC unit outside that I could like start running and then start running a fan. It gets noisy. I really don't want to do it. Oh, okay. Yeah, you had to bring a fan in. I could hear your fan, Zach. Yeah. You were still what I should say. I could still understand what you're saying, but I could definitely hear the fan. I heard the fan as well. I'm like, oh man, Zach is pumping some sort of air. Yeah. Here, I mean, I can run this fan right now. Let's see how much you guys can hear it. Probably not too bad, but that should already start decreasing the temperature a little bit. Okay, is this the one, equity you want help with? G and H are given by 2 log base 3 of x. H is 4 cosine squared of x. Solve g of x is equal to 4. Okay. That's not too bad, right? Did we have any rules about the domain of g? No? Oh, this is not bad then. Okay, fine. So, 4 is equal to 2 log base 3 of x. Divide by 2, divide by 2. 2 is equal to log base 3 of x. So, by the base answer power BAP rule, right? This is the same thing as you could just raise both things as like 3 to the. This goes away. And you get 3 squared is equal to x. So x is equal to 9. Not too bad, equity, right? Just some simple log rules. I was hoping they would decompose them as well. Okay. What's the other one? 4 cosine squared of x is equal to 3. Okay, so cosine squared of x is equal to 3/4. So cosine of x is equal to plus or minus the square root of 3 over 2. And I have to do that on the interval of 0 to 2 pi. This is a special triangle.
My man.
Right, yeah. So that is going to be the 30, 60, 90, my boys, right? This is 30, this is 60, and then this is 90. This is 1/2. This is square root of 3 over 2, and this is 1. So on the unit circle, cosine equaling, so that's adjacent over hypotenuse. Oh, well, this is the adjacent. That's the hypotenuse. Duh. Okay, fine. So here, yeah. X is equal to 30 degrees. You're cooked? Raven, you'll be fine. The other place it could happen would be negative 30 degrees, but that's not allowed in our domain. And then also I could have had like cosine of x was equal to the negative square root of 3 over 2. But that happens over here when this is 30 degrees. And so that's really like 150, which is still not in the domain, right? So you only have one answer here. 30 degrees. Which they probably want it in radians, so fine, whatever. Pi over 6. Oh, those are actually pretty quick. I could probably do some more, actually. That's actually... you know what, like, made me scared? Was, like, all of this. Like, what is all this shit? It's, like, way too much, like, way too many instructions. Here, I think I can do these, actually. Let's just do these. I'm sure we can crank them out. This is what I call, like... This is like calisthenics, you know, for math. This right here, this is like powerlifting, you know? It's like really intensive. You're not really putting that much like distance into what you're doing, but you have to like exert a lot of like instantaneous power. This is another example. Well, this is like running a marathon. Because this is like long and it's intensive. This to me is long because like there's a lot of questions, but it's short effort. So it's like calisthenics, like math calisthenics. Okay. Rewrite J. Yes, cool. A single log base 2. Yep, that's good. Oh, no, we lost it. Come back. So, log base 2 of x plus, and then I'm going to say this is log base 2 of 2 to the third. So what I like to do is anytime I see this, I like to bring it back up top. So this is really log base 2 of 8. And now I have two logs that are adding each other, which is the same as a single log multiplying. So this is log base 2 of 8x. And then for the next one, rewrite in which tan x appears only once and no other trig function is involved. Sure. So 6 over tan x cosecant squared x minus 1. This is probably an identity. I just forget it. Is it like 1 plus tangent squared is secant squared and 1 plus cotangent squared is cosecant squared? I think so. If you're unsure, you can always rederive it. So I say it's the same thing as 1 over sine squared. Yes, exactly. So 1 over sine squared minus 1 is the same thing as 1 minus sine squared. And this right here is cosine squared. So here, let me do it, sorry, in order. Because yeah, I kind of skipped a lot of steps there. Okay, sorry. Cosecant squared x minus 1. Right, so the other way to say is that like cosecant squared x minus 1 is the same thing as 1 over sine squared x minus 1, which is the same thing as sine squared x is the same thing as 1 minus sine squared of x all over sine squared of x. Sorry, I was screwing up. So I multiply this by like sine squared over sine squared, and then I can combine them. And now this is cosine squared. So this is cosine squared x over sine squared, which, yeah, look at that. That's cotangent squared of x. Cool. So, yeah. Okay, so 6 over tan x, and then this is 1 over tangent of x, tangent squared of x. So that's 6 over 1 over tangent of x, which good is equal to 6 tan x. Nice. All right, that's not bad. Part C. Let's crank it. These make me feel good. These are like little wins, little math wins. I love little math wins. So happy. Thank you, Equity. Thank you for these math wins. Okay. Blah, blah, blah. Okay. This is a quadratic function. Anytime you see something squared, something to the first, and something like to the 0, it's quadratic. So this is the same thing as e to the x squared minus e to the x to the first minus 12 e to the x to the 0 equal to 0. This is a quadratic equation. U equals e to the x. Then you have u squared, exactly, yep, minus u minus 12 equals 0. This is factorable. This is u plus 4, u plus 3, u minus 4 is equal to 0. So u equals negative 3 or u equals 4. Good, very good. E to the x equals negative 3. E to the x equals 4. This one doesn't make sense because e to the x can't be negative. This one does. X equals ln of 4. Yeah. Cool. We did it. Happy, happy, happy. Nice. GG, dogs. Yeah, you're very welcome, Equity. Oh, message me, Equity. You won the summer camp thing, and also you have money from Wibbly. Like, check all the stuff you won in my server, please, and just DM me what you want. If you don't play video games anymore, just find me a gift card thing that is kind of legit and not a Visa gift card. Some people ask for like Spotify subscriptions or like ChatGPT gift cards or all sorts of other stuff. As long as it's like kind of education related, you know. I'm not gonna buy like an OnlyFans subscription for you.
You done messed up, Aaron.
But if it's related to your learning, I'm cool with it. All right. Okay, here we go. Equity says, I also have a question. Is taking AP Bio, AP C, and A Push... I swear I've bought ChatGPT. I've gifted ChatGPT for people before. I guarantee you I have. Discord Shop's fine too. I mean, you can learn stuff from Nevermind. I don't think that's too much, Equity. You're a smart kid, dude. AP Physics is going to be the hardest for you. But luckily, you know, I teach physics for a living, so you can get a lot of help here. AP Bio is just fucking bullshit. It's just memorizing stuff. There's not the only difficult thing about AP Bio is like, where's the mitochondria? Where's the powerhouse of the cell? You don't really have to do much think. And then yeah, A Push is again just memorizing a bunch of stuff. And then if they still have an essay component, you have to kind of figure out what essay format they want. Do not drop AP Physics. No. If anything, I drop AP Bio. Yeah. AP because I know you, Equity. You've been in my server for like probably 2-3 years at this point. Like, you can handle AP Physics 100%. And it's probably the most useful AP you will take. It is the toughest, 100%. In terms of like pass rate, AP Physics is the worst. Because usually the teachers that are assigned to AP Physics in high school are terrible. I was lucky. I was blessed with a really awesome physics teacher. His name's Mr. Ripito. Shout out Mr. Rip from like Houston. And because I had a really good physics teacher, AP Physics was not that bad for me. And then probably the reason I got into physics as like undergrad, grad, career. So the teachers don't teach at my school. Yeah, so that's the thing. If your AP Physics teacher is absolutely atrocious, then yes, maybe hold off on taking AP Physics because it's going to be tough. It depends how much you're cool with self-teaching or getting help outside the classroom. Like, if you want to get help from me by showing up to streams for AP Physics, I'm more than happy to do that. I teach physics every day. If you're going to the biomed pathway, so that's actually kind of a misconception. You probably want AP Physics because, even if you go into like pre-med in college, you have to take physics in some capacity. And if you can get that credit out of the way from high school, you're going to be doing a lot better. Because otherwise, you need to compete with other pre-meds who suck in a college-level physics class, and that is brutal. Because most professors curve, and then you're having to beat the curve, and you're going against pre-meds who are like really aggressive on grades, and you're going to have a bad time. My physics for pre-meds class was different because I didn't give a curve, and I wanted people to like help each other. So like, but that's a rare case. Most times in college classes for pre-med physics, it's brutal. And if you can get that out of the way by getting credit with the AP exam, you're going to be much better on your pre-med track in college. Everyone's going to take biology anyways in undergrad, and you honestly might even have at my university. I still had to take bio because you needed a 5 on the AP bio exam, and I got a 4. I was so mad at myself. You need 2 physics credits in college, and usually AP Physics C counts for both, right? If you take the mechanics and the E&M form, or are you just taking mechanics? Oh, you're just taking mechanics. Okay, so that's 1 credit then. But it's still useful. So yeah, AP Physics Mechanics pre-meds is literally what I taught last quarter at UCLA. And if I had the choice between that or biology to get out of the way in high school, I would choose physics. Also, physics is the, what do you call it? It's the weed out class for pre-meds. In addition to Orgo, like OChem is also really difficult. But a lot of kids who want to be doctors are really good at memorizing things, but they're not very good at like critical thinking physics stuff where you can't memorize things. It's about knowing the process and applying systems. And so physics tends to weed out a lot of the kids that want to be doctors because they can't get past the physics. It also screws them on the MCAT. The physics section of the MCAT is legendary for like really like selecting out who's going to become a doctor. So get as much exposure as you can to it before you go into college. It's the thing that'll differentiate you the most as a pre-med. Yeah, I love AP Chem. AP Chem is great. Definitely do AP Chem. That gets you out of two semesters of college, usually. I did AP Chem. Got me out of all my chem credit. It was great. Zach says, I've heard of a special calculus course that was offered by a mathematics department whose purpose was to act as a weeder for the business school. I hate how math, physics, and editing act as a weeder for majors. Yeah. It gives us a bad rap. For sure, Zach, because then people just see it as like some nightmare hard thing that's like not actually enjoyable to learn. It's just meant to like block kids. Yes, magnetism is probably the hardest for sure, but that's what I'm teaching right now. If you come by my lectures at 12:30, like for the next 3 weeks, I'm teaching E&M. You could literally learn E&M from me, like if you just spend the next 3 weeks on YouTube. I support euthanasia for those who fail math. Yeah. I mean, here's the issue. Everyone wants to become doctor, lawyer, accountant, right? That or their parents want them to become doctor, lawyer, accountant because their parents want a fucking retirement investment, you know? They're not dumping all this money into their kids' college education so that they can go learn about, like, Romeo and Juliet. Like, they want their kids to get nice degrees that get nice jobs so that they can pay for them, you know, their retirement type stuff. And when you have that much demand, you have to start implementing some sort of weeder thing, some weed out system to really select for who really wants it, you know? And unfortunately, math and physics are really good at being like weed out courses because to put it in gaming terms, there's a really high skill ceiling, right? The skill ceiling on physics and math can go like kind of infinite. With biology, you can top out pretty quick. It's just like how much can you memorize? So exactly, and AI is just gonna make it worse, 100%. Because the memorizing courses, biology or like any of these writing courses are all gonna just get like janked out by AI, and now you start really needing to crank up the difficulty. I'm finding this in my own class I'm teaching online right now at UCLA. I'm having to design an exam that is a little bit more difficult than usual because I know kids will cheat and use AI, and I need some way to like level the playing field. But yeah, math and physics have a very high skill ceiling, and they really test for who really wants it because you have to be willing to put in like the time to practice something that's difficult in order to do well. And that does select for success, because if you're willing to like put in the time and effort to master something that is difficult, you're more likely to, I guess, I don't know, like solve cancer later. Because it's like going to the gym. If you lift a lot of heavy weights, I would trust you to carry me out of a burning building. So if you're able to get through a weed out course, which is math or physics, in college, then I trust you to, you know, diagnose me with like whatever symptoms I have. I don't know. Yeah. AI already is good enough to solve math and physics. It really is. It's scary how good it is. It's probably at grad level right now. Is physics important for forensics? Could be for like bullet forensics. You know, if you're talking about trajectories. I don't know. Probably some other stuff with like collisions, impact. Biology and chemistry are definitely important for forensics, right? Because that's all the DNA stuff. Good job on Jaden on your math exam, by the way. You can trick AI by including irrelevant information. I've seen you do it on stream. Yeah. Yeah. Don't give out all my secrets, Jeff. What's the difference between college and university in the US? No difference. It's the same thing. I think college is seen as like a lower thing in like the UK or something. What is 6 divided by 2 times 1 plus 2? 1. Well, or 9. Sorry. I did an online multivariable calculus course during COVID. I remember having to do some different things for assessment and result. Assessment divide. Yeah, 100% Zach. That's what I'm going through. I'm giving my first test out on Friday. And luckily it's only 10% of the class. It's only 10% of the grade. So I'm not too concerned if everyone somehow finds a way to like bypass it. But I try to really inspire in the students that if you're cheating now, you're going to get screwed later. Like you're just cheating yourself. Like, you're going to get caught. You might as well learn it. We do oral exams at the master's level too, yeah. Yeah, it's called we call it Advanced to Candidacy, ATC. It's also called an oral defense or like thesis proposal, usually what it is. Yeah. Also depends on the field. Like, I know some other fields, yeah, they do oral exams at every level. Physics really only does it for to get your master's and then to get to your PhD. Okay, what is this? A circle of center A has radius 4. Cool. That's dope.
That's dope.
Center B. Oh, wait, what? A lies on the center B, radius 3. Ooh, okay. So what's going on here? Yeah, sorry, Shanchix. We're doing your question now. It's all good. I appreciate people asking like the life questions about things because I've lived a fair amount of life at, you know, the ripe young age of, fuck, how old am I? 30, 35? Yeah, 35. I've seen a lot, so I'm happy to share what I've seen. Okay, sure. It's perpendicular to MN. Okay, so we know this is perp. Also, MM is tangent to the larger circle. MC and NC are each tangent at D and E. Okay, cool. I don't know. I'm gonna like draw something like this maybe. Who comes up with these shapes, dude? I want to know. Like, who dreams up these shapes? Looks like some sort of cult symbol or something. Determine the area of MNC. Okay, nice. Okay. So they want the whole area. They want this. Cool. Yeah, bro. Yeah, isn't this the Horcruxes? Or the Deathly Hallows? This is a Deathly Hallows cult thing. Yeah, this looks like the Deathly Hallows. I know this is like we create some triangles. I know I know what we're doing here. We end up doing this. Right? This is a triangle. And then yes, they all equal 4 exactly, right? Yeah. Oh, is the orthocenter? Yeah, you're right. Yes, it is the orthocenter. You're totally right, Zach. Yeah, because if it touches all three sides and it's perpendicular, then it's the orthocenter. Intersection of three altitudes. Correct. Nice. That is true. Okay. Which maybe there's some property of orthocenters. Okay. I know this is also equal to 3, right? And then let's call this equal to x. We'll call this equal to x. Okay. And so that'll tell me what, like, this to this is based on, like, this to... Because these are similar triangles, no? Is EM congruent to EC? Not necessarily. But maybe. Because this is another triangle I can draw, right? Which I know is congruent. So I know that x over 3 is equal to x plus 3 over 4. If I compare these triangles, right? Or here, let me do it this way. Yeah, I don't know. I'm just like solving shit. I just like to get this is my brute force method of I just like start solving for sides. And I know I need the height. Once I get the height, then we're halfway there, right? I just need the base. Okay. So what is this? 4x equals 3x plus 9. Cool. X equals 9. Wow, Femvox already got 64 square root of 2. Good job. Boom, boom, boom. Okay. So I know the height now, right? So height is equal to 9 plus 3 plus 4, 16. So from what Femvox says, I'm pretty sure this is like 4 root 2, but we just got to show how it's 4 root 2. Okay. Oh, you're right. Yes, it's 1/2 base times height.
Oh, no.
I screwed up. Yep, you're totally right. Totally right, Zach. Totally right. Okay, how do I show it's 8 square root of 2? Where is that square root of 2 coming from, by the way? What? Okay, wait a minute. I think I can maybe get this angle. Pythagoras, maybe sponged. I think if I know this angle from this being a triangle, then I know this is double this, and then this must be half of whatever 180 minus, right? Let's try to do this. Okay. So, let's say this is like some angle theta, right? So sine of theta is equal to opposite of our hypotenuse, right? 3 over x. He says, you know CMT is complementary to MCT. Yes, correct, because this makes a right triangle. You're totally right, Zach. Oh. Okay, watch what happens here. Okay, cool. So sine of theta, right, is opposite of hypotenuse. So that's 3 over x. And then I want to know this. Oh, wait a minute. Wait, whoa. Do I even really need to know this? Wait, sine of that, is that over that? Okay. And then sine of theta is also equal to this mt over 16, right? Am I crazy? Oh, okay, no. That's not sine of theta. That's, sorry. Because this is not the hypotenuse. Sorry. That's tangent. Tangent of theta is equal to mt. Thank you, Jeff. Is mt over 16. I got confused there. Yeah, this is the hypotenuse. Okay, perfect. Okay, here we go. And x is equal to 9. So sine of theta is equal to 1/3. Skibidi toilet bundle. I'm glad you can. What's the skibidi toilet bundle? Okay. So if I do sine of theta over tangent of theta, that's sine over cosine.
Oh, you got that. Thank you, Zach. Zach got the baby voice going. So cosine of theta is equal to 1/3 over mt over 16. Okay, and I already know sine of theta is 1/3. Okay, so I can draw like a triangle, right? Yeah, let's draw a triangle. Okay, watch. This is theta. Sine is opposite of hypotenuse, so that means this is square root of
8, right? So the effect of helium on the vocal cords, right? Which we said is not the vocal cords; it's the air inside the cavity. He's like, did my sound card just blow? Okay, this is very cool, guys. So cosine of theta is equal to the square root of 8 over 3, and that's equal to 16 over 3, 1 over mt. These cancel. So square root of 8 over 16 is equal to 1 over mt. So mt is equal to 16 over 2 root 2. So that's equal to 8 over root 2, which is, yes, 8 root 2 over 2, which is equal to 4 root 2. Okay, cool. All right, this is 4 root 2. So this whole thing is 8 root 2. Okay, very cool. So then height is that. Base is equal to 8 root 2. 1/2 8 root 2 times 16. This cancels. 4 root 2 times 16. We get 64 root 2. Same as Fembox. Good job, Fembox. But Shantrix, is the correct answer 64 root 2? This is kind of a heater of a question. I take the dub from Zach. I like the dub from Zach. I'm waiting for the official judge. I'm getting better at these fucking triangle circle problems. They're not so bad. You start noticing patterns. It's always like law of sines or trig this, cosine this, and then like some Pythagorean stuff. As long as I don't have to draw any auxiliary lines. No auxiliary lines. Yes, it is correct. Awesome.
Oh,
yes.
We're so sorry to hear about your brother that passed away. He gets 5
All right,
big
5 big booms for us. Cool. Good question, Chance.
Well done. Well done.
Nice. Okay. I think that's all the questions from today. So let's wrap the stream. Cool. All right, thank you everyone for coming to office hours. Had a lot of fun. What's up, Pantheria? Had a good time asking a bunch of questions today. I appreciate learning with you guys. Appreciate my UCLA students that came by and asked about fluid dynamics. Oh, this was the solution? Ah, yes. See. Aha. They use Pythagorean theorem. Okay. Cool. 64 root 2. Nice. Okay, that's our last office hour stream of the week. I am still teaching physics tomorrow at 12:30 for UCLA. If you want to come by and learn some E&M, we're going to go over like more of Gauss's law. Otherwise, if you haven't already, join our Discord. It's right there. And you can participate in our summer camp we're doing this summer, where we're playing video games, learning math, and you could win a Nintendo Switch too. It's dope. Make sure if you just found us on Twitch, I'm not the only person that does this. We have a whole other slew of awesome math streamers that you should go follow. There's their list. I need to update this list. But the calendar is updated. So if you ever go to the calendar there, of course, yeah. Thank you, Zach. Appreciate all of y'all's guys' input. But yeah, if you go to the calendar here, you can see the next streams that are coming on. So looks like Penn Center's got a machine learning stream on Friday, and Zach will be streaming math on Saturday. So, and yeah, I'm going to do Gauss's law tomorrow for UCLA kids. But you can still come by too. It's free. It's open. Okay, cool. Let's go find someone to go raid. We're going to go raid today. Let's go raid somebody. Ooh, yes. Ask a Scientist Gaming or Moo Hoodles. They're both great. I tend to like... Oh, this guy's doing family science, couples therapy, and X-Men. Oh, hell yeah. And he looks like he's playing Space Invaders. Yeah. Yeah, Zach had a really long stream. I hope he's feeling better too after that. Zach, you didn't actually get sick, did you? Okay. All right. We'll see you. Our next stream will be on Monday at 3 p.m. Pacific. Come on by then. Enjoy the weekend. Have a great time. Peace.